In this lesson, we're going to be solving quadratics. In this one, we're going to be using a square root to solve it. So there's a recognition to this. So we have to recognize when we can and when we cannot use a square root. So our equations, sometimes they're going to be in the general form, standard form. Sometimes they're not. So in this particular, so we'll do the first one. And there's always multiple ways to do this. We could use quadratic formula, solves every single quadratic in standard form. We could try and factor, but sometimes there's a most efficient method based on the problem. And this happens to be the square root is going to be one of the fastest ones. And so our recognition is on this one, we have no b value. All right, so the b value is just the value with an x. We don't have that. So we're going to try to isolate the square to solve it. All right, and then we're going to check it with a calculator or with a graph. So to solve this, we're going to try to isolate that piece right there. So to isolate it, we are going to subtract or add the 25 over. We're going to get rid of the subtraction of 25. So we'll add 25 to both sides, which is going to give us an x squared equals 25. And then we're going to try to get rid of the square root. So to get rid of the square root, we will to get rid of the square, we'll square root both sides. So if we bring in the square root to solve, squares and square roots undo each other. So that'll leave us with just an x. And then that's going to equal the square root of 25, which is 5. But because we brought it in, we'll always get two answers. So it's a plus or a minus 5. Because if you square positive 5, you get 25. But if you square negative 5, you'll also get 25. So we are believing that we have two solutions to this. And if you've graphed quadratics before, you know that when you solve a quadratic, and when it's set equal to 0, and you solve a quadratic, those are actually the x-intercepts. So just kind of a side note, those are our x-intercepts. So we have a 5 and a negative 5 for our x-intercepts, so that's how we can check it. We could check it by plugging it back in, seeing if it adds up to 0, or sometimes even quicker, we can just graph that equation and maybe. Okay. We could graph the equation and just look for x-intercepts. So if we graph it, it has this y-intercept way down here somewhere. And we're looking for x-intercepts. So we have an x-intercept here at negative 5. And we have another x-intercept here at positive 5. So our graph checks out. Our solutions check out to our graph. All right. So let's do another one. So this time it's going to look a little different, but it's going to have the exact same math to it. All right. So same kind of a thing. We don't have just an x here. We have this whole term that's squared. It's very similar to that. We don't have a piece that just has an x that's outside of the square. So we're going to isolate the square just like we did here, which we already have. This piece is isolated. So then we can just square root both sides to solve. So we will square root, and square rooting cancels a square, so that will just leave us with an x minus 5 is going to equal a plus or minus 4. So again, if we introduce the square root to solve, we're going to get a positive and a negative of that. So we have two situations. We have an x minus 5 equals 4, and an x minus 5 equals negative 4. And we just solve each one individually. So we'll add 5. We'll add 5. And that'll give us two solutions. X is going to equal 9 on this one. X is going to equal 1 on this one. So again, those are our x-intercepts. It's kind of a side note. So we could plug them back in. Make sure that they add up to 16 after you do the math and square it. Plug in a 1, do the math and square it, or we can go back to our graph again and we'll graph the other one. So there's our 1, 2, 3, 4, 5, 6, 7, 8. So our first x-intercept is a positive 1. Our second x-intercept is a 9. And so it checks out. Okay, so those are our solutions. All right, we'll do one more. Oh, to check it, I didn't type it in like this. I have to have it equal to 0 in order to check it, because I'm looking for x-intercepts. So I needed to manipulate this equation real quick. And so I did the x minus 5 squared. I brought the 16 over, so subtracted it. And then it was equal to 0. And then I just graph it as a y equals this quadratic. And then that will give me my graph like this, which then I can solve it, or I can check the x-intercepts. All right, so number 3. X plus 2 squared minus 12 equals 0. So that thing's ready to graph, which I'm going to do eventually here. But we need to isolate the square in order to be able to square root both sides. So we'll add 12 to both sides. And that'll get us a x plus 2 squared equals 12. We're going to try and get rid of the square by square rooting. And that will give us an x plus 2 equals plus or minus. Now we want to try and simplify this as best we can. 12 has a perfect square of 4, and 3 would be the other value to it. So we have a plus or minus. The square root of 4 is 2. Square root of 3 we can't do. So our answer again is we have two separate equations. X plus 2 equals 2 square root 3. X plus 2 equals negative 2 square root 3. So we'll subtract 2 for everything, and that'll get us x is going to equal a negative 2 plus 2 square root 3. They're not like terms, so I can't put them together. And x equals negative 2 minus 2 square root 3. Now, to check this, these are the exact answers. But that doesn't really help if I'm going to check it. It also, the reason why we were doing the graph is because these are hard to plug in and do the math and make sure it actually works. So there is an easier way, and it's checking your x-intercepts. That's why we were talking about it on those. But I don't know where negative 2 plus 2 root 3 is as a value on here. So what we can do instead is turn them into approximates. So plug this into a calculator and round. This first one will get roughly 1.46. The second one will get roughly negative 5.46. So those will help us to actually look on our graphing calculator to make sure that it actually works. So let's turn that equation on. Maybe. Okay, so let's get an idea that we're looking for about 1.5 and about negative 5.5. So if I zoom in on this a little bit, here's our first x-intercept between 1 and 2, and it's a little bit shy of a halfway spot, so that looks good. And then if I move over to the other one, I should get a y-intercept just in between negative 5 and negative 6, about halfway, which mimics that one perfectly. So these are our approximates, these are our exact answers, and it depends on what we're looking for, but a lot of times you're going to want both. Usually exact answer is what they're looking for, but an approximation is going to help us to actually double check that it works. All right, and that was solving quadratics with a square root.